Hey everyone, and welcome. If you're building with generative AI, it can feel like you're trying to assemble a spaceship in the dark. Well, today, we're going to flip on the lights. We're going to break down this whole complex Gen AI ecosystem into a really simple, powerful framework. And let's just start with the sheer scale of this whole thing.
And yeah, there is a very good reason to get this right. The market for large language models is projected to be worth over $36 billion by 2030. That is a massive, massive opportunity. But with that opportunity comes a ton of noise and, frankly, a lot of complexity. And that's the real question, isn't it? For every single developer, startup, and big company out there. I mean, with new models, new frameworks, and new platforms launching what feels like every single week, where do you even start? The number of choices can be completely paralyzing.
So here's the answer. The trick is to stop seeing it as this chaotic mess and start seeing it as a set of building blocks. This is what we're calling the modular architecture of generative AI. It's a way of thinking that lets you pick and choose the right components for your exact project, from learning the basics all the way to deploying at a massive scale.
So here's our game plan for today. First, we'll really get our heads around this core idea of modularity. Then we'll dive into the foundational algorithms, the what behind it all. Next, we'll get into orchestration, the how. Then we'll tackle that huge where decision, cloud versus hosting it yourself. We'll see how it all comes together in a real-world case study, and finally, we'll take a peek at what's coming next. So, the most important takeaway is this. Think of the entire Gen AI space as a giant set of Lego bricks. Seriously. Every piece, whether it's a model, a library, a cloud service, is just a module. Your job as a builder isn't to invent everything from scratch. It's to know which bricks to snap together to create something truly amazing. All right, before we can build anything, we need the blueprints and the raw materials, right? In the world of Gen AI, this means the core educational concepts and those fundamental algorithms that make these models actually work. This is our foundation.
Okay, at the heart of everything are a few concepts you just can't skip. Understanding the transformer architecture, that's like understanding how an engine works. Knowing techniques like parameter-efficient fine-tuning, or PEFT, lets you customize models without breaking the bank. And getting RLHF, or reinforcement learning from human feedback, is absolutely key to making models safe and actually helpful. These are the core skills, the real foundation for any serious Gen AI project. And the great thing is, there are learning modules for everyone. It doesn't matter if you're an engineer who needs to go super deep on the LLM lifecycle with deeplearning.ai, or if you're a business leader trying to figure out the high-level strategy with MIT. There is a structured path for you to get the expertise you need. So, how do we actually teach an AI to be helpful and safe? Well, that's where a critical module called reinforcement learning from human feedback comes in. It's a three-step dance. First, humans act as teachers. Imagine you ask for a cookie recipe. One AI gives you a sloppy list of ingredients. Another gives you the full step-by-step recipe. You, the human, rank the full recipe way higher. Step 2, a separate reward model is trained to learn that preference. It learns what good looks like to a human. And finally, the main AI model is tuned over and over again to get the highest possible score from that reward model. It basically learns to always give the useful, complete answers that we prefer. Okay, so we have our foundational knowledge, we have our core algorithms, but how do we actually connect all these pieces to build a real application? That's where orchestration modules come in. Think of this as the glue code that holds the entire system together. This is the developer's toolbox, and picking the right tool is everything. If you're building a really complex app that has to chain multiple AI calls and talk to a bunch of external APIs, LangChain is your Swiss Army knife. But if your whole project is about creating a powerful search engine over your company's private documents, you'd probably start with LlamaIndex. And for the really advanced stuff, Crew AI lets you build entire teams of specialized AI agents that can collaborate on a single goal. It's pretty wild. So you've chosen your tools, you've glued your modules together, now you've reached one of the biggest, most strategic decisions you're going to make. Where does your application live? And this choice has huge, huge implications for cost, for control, and for how you scale. And listen, this isn't just a technical question, it's a business question. Are you prioritizing ease of use and having someone else manage all the messy infrastructure, or do you need maximum control and total privacy over your models and your data? Let's break down the options. So which do you pick? Well, if your strategy is all about model diversity and you want to avoid getting locked into one vendor, AWS Bedrock is basically your marketplace. If you're already deep in the Microsoft world,
and you just want the most direct path to the latest OpenAI models, then Azure is the obvious choice. But if your application's success depends on processing enormous documents, I'm talking legal analysis, summarizing entire books, Google's Vertex AI, which is built around Gemini, is designed from the ground up for that massive, massive context window.
But what if you want to go it alone and host everything yourself? For high-traffic, production-level apps, VLLM is the engine of choice. It's built for absolute maximum speed and throughput on really powerful GPUs. But for development or for apps where privacy is the #1 concern, Llama is fantastic. It lets you run incredibly powerful models completely offline right on your own laptop.
Okay, theory is great, but let's see how this whole modular approach actually works in the real world. We're going to look at a super ambitious project that combines a lot of these modules to tackle a huge problem in healthcare. So our case study comes from a team called Loki Laboratories, who are part of the AI for Barth hackathon. And their goal wasn't just to build another chatbot. They wanted to propose a brand new scientific paradigm for fighting virulent diseases.
This diagram right here shows their incredible vision. Instead of a traditional vaccine, they imagined an AI-powered platform. If you just follow the flow, you can see how it starts with AI discovering natural compounds, then it predicts their antiviral effects, all to create what they call a universal health shield that primes the immune system.
And now, look at this. It is our modular architecture in action, right there on the screen. They've taken this unbelievably complex problem and broken it down into 5 distinct, manageable modules: an AI discovery engine, an immune pathway activator, an antiviral engine, a monitoring system, and finally, the protection platform. Each module has its own specific job, but they're all designed to work together perfectly. So we've seen how to build applications today, but where is all of this going? Well, the next major shift is already happening. We're moving from models that just generate content to systems that can actually perceive their environment and take action. This quote just nails it. Agentech AI is the next evolution. It's about creating systems that can understand a really complex goal, like plan my business trip to Tokyo, and then create a multi-step plan using different modules, and then actually execute that plan by booking flights, reserving hotels, and adding events to your calendar, all on its own. And this is the most crucial takeaway. All these modules that we've been talking about, the models, the orchestration frameworks, the data tools, they are becoming the building blocks for these more autonomous agents. We're slowly moving from building tools that we command to building teammates that we collaborate with. And that brings us right back to you. The power of this modular architecture is that it's not some rigid prescription. It's a framework for thinking. It doesn't matter if you're building a simple chatbot or a complex scientific discovery platform. The principles are exactly the same. The future of AI is being built one module at a time. So the only question is, which ones will you use to build it?